In this lesson, we're going to be looking at finding the arc length for a sector. So the arc length is the length of this little piece that would end up being part of the circumference. And so you'll see now that to find this, we have the measure of arc AB divided by 360 that represents some fraction of the circle. And then we're going to multiply that by the circumference. So just remember we have like a part of the circumference. And so the way we represent the part is with the fraction. The word of represents times, and then your circumference is defined as 2 pi r. Next up, we have a couple of examples. So first thing we're going to start with is we're just going to find the circumference of this entire circle. So the circumference is defined as 2 pi r, and in this case we have a diameter of 16, and so the radius would be 8. So this is 2 times pi times 8, which gives you 16 pi. So this would be an example of leaving your answer in terms of pi. If you were asked to give a decimal, then this is approximately 50.27. And these are lengths, so we would have like just the unit. So if it was feet, inches, centimeters, whatever that may be. So here's our circumference, and I'm going to need this number on the next several steps here. So next up we have the arc length of xy. xy is this little piece, so you can see here obviously that's part of the circumference. And which part is that? Well, if we write down our formula, so we've got some part of 360, so that little box right here tells me we've got 90 over 360 times my circumference, which is 16 pi. So now when I multiply this out, what I would end up typing in the calculator would look like 90 divided by 360 times 16. And then what happens is you just kind of hold off on the pi, and you would know that when the calculator spit this number out, so this ends up being 4, that you would add the pi on at the end. So this is 4 pi, and you should be able to say to yourself, well, this makes a lot of sense because that's 1/4 of the circle, and so 1/4 of 16 is 4. Again, though, if you were giving a decimal representation, I would just type 4 times pi or 4 pi into the calculator, and that's approximately 12.57. Next up, we have the arc length of wx. So when I look at wx is also 1/4 of the circle, because we know, for instance, here if this is 90 degrees, then over here is supplementary to it, and so it's also 90. So this will still be 90 over 360 times 16 pi, but again, I know it's going to be the same answer as the previous problem, so I'm just going to write 4 pi up here, which is approximately 12.57. Last up, we've got the arc length of wzy, so w to z to y. This is half the circle, so there's 180 degrees there. If I show the substitution into the formula here, we'll have 180 over 360 times 16 pi, and same thing if you were typing into the calculator, it would just be 180 divided by 360 times 16, and so this will give you 8, and so then when you write your answer, you just throw the pi symbol on at the end. And again, this makes sense, you guys. We have half the circle, so if our circumference was 16 pi, half of that should be 8. And the decimal equivalent here is 25.13. Last up, we're just going to add all of our arc lengths together. So the length of xy, so that is right here, that's 4 pi. The length of arc wx was 4 pi, and the length of wz was 8 pi. So 4 and 4 and 8 gives you 16. That's the distance around the whole circle, and don't forget that pi symbol. Here we're first asked to find the circumference. So circumference is defined as 2 times pi times the radius, so 2 pi r. In our case, r is 12, so this will be 2 times pi times 12. and that gives us 24 pi as an exact measurement. But if I were to type that into calculator, that's approximately 75.4. Now on for the arc length, we're trying to find the arc length of arc PQ. Oops, let me switch over to the highlighter here. So this piece right here. So when I go to write out the formula, we'll have 135 over 360 times our circumference, and so I know the circumference is 24 pi. And so when I type this into the calculator, these would be the buttons I'm actually pushing. And so that gives you 9, and then you maintain that pi symbol. So this is going to be 9 pi or 28.27. For this example, the circumference of the circle would be 2 times pi times our radius, which is 15 feet. So this is 30 pi feet. And so now we have units, so I'll go ahead and include them. This is approximately 94.25 feet. And then when I move on here to figure out what my arc length would be, notice that we have a major arc in this case. And so we've got X to P to Y. And so I can figure out what this arc measure would be. We know that 120 is the minor arc at the top. So if I take 360 minus 120, you can see that 240 is the part of the circle I'm asked about. So 240 divided by 360 times our circumference, which was 30 pi. And so then when I calculate this, that gives us 20 pi. If you want to multiply that out, that's approximately 62.83 feet. For our last example, we're throwing in some vocab that you should know. So what they tell us here is that the measure of arc YXZ is 305 degrees. So that's a major arc because we've got our 3 letters. So here's Y, X to Z, and I know that that is 305. So then to find this missing arc measure, we would take 360 minus 305, and that's 55 degrees for the arc measure. So to find the arc length of that arc, we'll take the part of our circle, so 55 out of the 360, times the circumference. And so I haven't found the circumference yet, so I'm going to choose to just write this as 2 pi r, and then I'm going to make a note here. This is really 2 times pi times 5, which is our radius. And so then I can say, I've got 55 over 360 times 10 pi, and that will give us our answer. So this isn't really a nice number, so 55 divided by 360 times 10 gives you 1.527 repeating, and then I would put the pi symbol on. And so generally when they're not nice like this, when the answers aren't nice like this, we prefer the decimal equivalent, which is approximately 4.8 feet. And so when I say decimal equivalent, you guys, I'm just saying that we're taking the original, that 1.5278, we'll say, and I'm actually figuring out what happens when I multiply that by pi. And so that's approximately 4.8 feet.